So as I was saying, a cylinder could be considered like just a prism with a circular base. So the capital B, for the area the base holds, right? And here's the formula for the volume of the cylinder. Volume equals capital B times H, but in this case, our capital B is what? Pi r squared, because that's the area of a circle. And again, the height and base always need to be perpendicular, okay? Even if it's oblique, you need to have some kind of different measurement. So let's just go on to a couple of these examples here. And again, the Cavalieri principle holds here as well, okay? If you have two cylinders with the same base area and the same height, they'll have the same what? What if you had a cylinder and a triangular prism with the same height and the same base area? Would they have the same volume? Yeah. Yes. Right? If the base areas, like if the area of the triangle and the circle are the same, and the prism has the same height, yes, it applies. Okay? So let's look at some examples. This one is pretty simple. The first one, pi r squared h. We got an r of 4, an h of 5. That's all we need, right? Pi r squared h, 4 squared is 16. 16 times 5 is 80, so 80 pi. Example number 2, not too tricky. They gave you a diameter, so the radius is what? 3, right? Don't forget to do that. So pi times 3 squared times 4, 36 pi. Now this one's got a little bit more going here, right? Looks like we have how many cylinders here? Well, 3, really, the hollow core center, right? So we have to add the volume of the bottom one and the top one, and then do what? Subtract the hollow one, right? And so they gave you the diameter of each, right? You cut those in half, right? So here is the volume of what looks like the bottom one, with a radius of 7, plus the volume of the top one with a radius of 5, minus the hollow core with a radius of 1. And you all know that 1 squared is what? I swear to God, anyone says 2.
1.
Okay, 1, right.
What if they don't do the diameter radius?
Well, not a whole lot you can do then. I mean, you know, if they don't give you that, there'll be some other way you'll have to find it. Maybe there's a triangle in there where you have to do trig, or I don't know, right? So sometimes they might not give it to you directly. In that case, you'll have to find it somehow, okay? All right, and so generally we're going to leave our answers in terms of pi, okay, unless they say otherwise. It's just a number of decimals, okay? Let's go on to the next page. I don't know, maybe a couple of these will answer your question, Charlie. So you all take a couple of minutes and find the volume of each of these 4, okay? First one should be straightforward, and you know, when they start putting little twists in them, okay? How about the first one? We got something now, yeah? And we got 165 cubic centimeters, all right? Pretty straightforward. So volume equals pi 4 squared times 10. You shouldn't even need a calculator, right? Because what's 4 squared times 10? 160 pi cubic centimeters. Circle your final answer. Anybody get number 2 yet? 75 pi. Everybody else get 75 pi? You know you did? Huh? Well, we better look at it. We've got a diameter of 5, right? So what's the radius? So the radius is 2.5, but we don't have the height. But you can't use that 13 because 13 is not the height, is it? So what are we going to do to get the height? Either Pythagorean theorem or a triple, right? Now remember the triple, do the Pythagorean theorem. What's the triple? So it's a 5, and this would be the work you show. That's it, right? 5, 12, 13, right? And then put 12 in there for the height. It's a lot less work than Pythagorean theorem. Wouldn't you agree? Okay, so now you can just do volume equals pi times 2.5 squared times a height of 12, right? That's 6.25 times 12, so volume would be 75 pi, right? Cubic centimeters. Okay? me give you a moment to get to number 3. A little bit of thinking about number 3. Add a couple things together, but first you'll have to find something. Shouldn't be too hard. On the triangular prism, you need measurements for base and heights and perpendicular, right? Segments there. Everybody get those at least? Oh, gosh. Let me ask you. Let's look at the triangular prism first. Here. What's the length of this side? Why is that 8? Because all radii in a circle are what? Congruent. That's just another radius, isn't it? So that's 8. Oh, and now we got a triple, don't we? What is it? It's an 8, 15, 17 right triangle. So this is 15. Now you got a base and a height, right? For your triangular prism. And the quarter circle, right? So you're going to modify your area of a circle by putting what in front of it? 1/4. Right? So you're going to have the triangular prism plus a quarter cylinder. And so volume will equal you combine terms that are not like terms. Remember, if you have a term with pi in it, it operates like a term with x, right? Now what do you say?
660 plus 176 pi.
176 pi plus 660. Anybody else get that? Okay. Or 660 plus 176 pi. Well, for the prism, right, the triangle, 1/2 times 15 times 8, right? Plus a quarter cylinder. So 1/4 pi 8 squared times 11. Everybody with me on that? You could have done the quarter cylinder first, right? So hopefully you'll get 660 plus what did we say, 176 pi? 176 pi cubic centimeters. Okay? And guys, those are not like terms. They won't combine. Okay? There's 660 pi, then you could. Right? Do we have any questions on that one? You get it now? You got to find things. Right, Charlie? They don't always give it all to you. You got to use the tools that you learned to find them. All right, let's move on to number 4. How many solids here do we have to deal with in number 4? Would it be 3? I guess maybe because I said solid, the third one is just air, right? That you have to do what with? Subtract it, right? What are the 3 solids we have to deal with? Well, let's name it. A half cylinder, and then what? What's the thing on the bottom? It's sitting on it. Rectangular prism, and then we'll have to subtract what? A smaller half cylinder. Yeah, there you go. Just to be clear, we're going to have a half cylinder plus a rectangular prism minus some other half cylinder, right? Or whatever order you put those in. Everybody get it yet? You got it?
Yeah.
Say it.
55 pi plus 132 centimeters cubed.
Oh, you're close. You're kind of close. Well, let's just say that that was a calculation to get monkey to the moon. Monkey. Yeah,
I plus 12 centimeters.
that monkey's going off to the further reaches of the universe.
Yeah. That's his goal. Monkey to a different galaxy.
Yeah, that's where you just sent him accidentally. Little error in the trajectory.
So I'm going to calculate.
Anybody have something else? It's all right to get this stuff on. We just make fun of you, torment you, humiliate you, right? That's when you decide to learn. Yes.
143 pi plus 12 centimeters cubed.
Your monkey was like his, but heading off the other direction. So it's space capsule. Charlie, what do you got there? Monkey gonna make it?
Pi plus 132 minus 16 pi.
Your monkey's not gonna make it either. Perhaps you should start with a German Shepherd. Well, I'll be just, I'll give away the end of the movie here. You should have 27.5 pi plus 132. Anybody have that?
I'm close.
You're close?
132.
Yeah? Well, I guess we better just look at it then. We need some measurements in here, right? So what is this total distance here? That's 6, right? Which makes this radius what? 3, right? If that's 4, what's this radius? 2, right? We're getting some numbers plugged in there that we need, okay? So now we can, so let's do the volume. We'll start with the top half cylinder, right? Volume equals not pi r squared h, but what? I said 27.5 pi plus 132. Yeah?
132. I got 55.
We get that?
And 24.5.
Yeah, we'll be okay. So let's see. The half cylinder, well, the one on top, I guess, right? So it would be 1/2 pi times its radius is 3 squared. What's its height? 11. And won't that be the height for all of these objects? Okay.
Well, I can include the half.
All right, it's a half cylinder, right? Yep, yep. So let's do the rectangular prism. Plus, what times what? Hey, yeah, so either way, right? Okay? Minus, you're not adding that cylinder in the bottom, right? Minus what? What's it going to be here? What? 1/2 pi 2 squared times 11, right? Notice 11's the height for all of them. I mean, they all, so it can be a little confusing, right? Because they all have their little individual heights and stuff, right? But then the height of the prism is, you know, that full length there. Okay.
I got it.
You get it now? So that one, let's see, would be 49.5 pi
Oh, yeah.
plus, that becomes our 132. And then we subtract, this becomes 22 pi. And now these are like terms here, right? We can combine them. Whoopsie daisy. Okay? It gives us our 27.5 pi plus 132 cubic centimeters. Okay? Fill it up. My monkey lived, yeah. Yeah, we're starting running out of monkeys here. I'm surprised there was one left for me.
Mine might have the edge of
We have to start breeding monkeys,
what's going on.
which is a job I really don't want to get into. Okay, so cylinders. Let's move on to some Regents questions. Here's our first one. Read it over, set it up. all the, remember, of course, again, we are proceeding as if it's not multiple choice written, so, right, the work's got to be there. Give you a minute. So hopefully now, I mean, you know, realize we got a half cylinder, a rectangular prism to add up here, right?
We need to take off the old.
No. Well, the whole thing is open underneath. I mean, if you took that out, there's really not a whole lot of volume, a whole lot of volume left except for the fabric it's made of. Could be useful in some situation. Anybody get choice one?
Yeah.
Here's choice one. Don't be scared, right? So, volume. Well, let's see. We need the radius of that half cylinder, which is what, 10, right? Okay, and then I think we're good to go, right? So 1/2 pi times 10 squared times the height of, what is it, 45? That's a big tent. That is a big tent. Plus the rectangular cylinder, 12 times 20 times 45, right? Everybody good with that? So then we end up getting, let's see, 7068. Yeah, I think you just had to multiply the height in there if that's what you did, right? 0.583 plus 10,800. Right? I'm leaving out 3 decimals because they want the final answer in the nearest cubic foot, right? And we're not like 3 decimals past that. So we add those up, we should get 17,869 cubic feet. Any questions on the first one? It's a lot like one of the simpler ones we did in the notes. Choice one. Figure out what, yep, got to do that. Pi r squared h. All right, let's move on to number 2. Rectangular prism minus that cylinder in the middle, right? So volume is going to be, what, 4 times 4 times 6 minus that full cylinder, right? Pi times 1 squared times 6 pi r squared h, right? So it gives you 96 minus 6 pi, and you just throw that in your calculator, and you should get 77 cubic inches. Choice 2. All right, moving along, number 3. We're not going to get through all of these. Trying to get through like number 6 or 7 because there's a thing I want to show you. Number 3, like, so if you read that over, and maybe you are pretty good at drawing sketches, you can sketch this one. It is a little tricky to sketch, I'll admit, but some of you are probably much better at me than that. But we'll see. I'll try my hand at drawing this thing out. That. So we got how many of those in there? Probably should have made it longer. Maybe I'll start with the tennis balls. That's what I should do. And draw my cylinder around it. I don't know why I didn't think of that before. So let me draw 4. And now they're too big. Jeez. Issues. Boy. 1, 2, 3, 4. It's not perfect, but we're not building a church. And each one of these has a diameter of what? 6.7. Which means I guess you'll need the radius, so what would be the radius for each one? So I'll just put that down on this one. 3.35, make that more clear. 3.35. Okay. Any thoughts on this one? Oh, choice? Well, okay. Not necessarily. I mean, thoughts on getting started. Yeah, did you everybody hear him? You're gonna need the height of that cylindrical can, right? How do we find the height of it? Yeah, right? So the height is the diameter of each one, and there's 4 of them. And what do you get? 26.8. So we'll just put that 26.8 like that. Right? Now we got a height. We got some radii in here, don't we? So the minimum volume of the can, in other words, they're going to be packed in tight, right? Do we now have our pi r squared h we can do? Yeah. So volume is going to be equal to pi times 3.35 squared. And now we know it's 26.8 centimeters high. What do you got there, guys? Yeah, like if you see none of these answers have pi in them, that means they put it in their calculator, right? Did you get 944.9 cubic centimeters? Yeah. All right, so choice 4. You round it correctly. Any questions on that one? Right, so you had to use the diameter of the tennis balls and know how many tennis balls are in there to get the height of the cylinder can, right? And then get the radius of the tennis ball, which would be the same as the radius of the cylinder, okay? All right, let's go on to number 4. Be careful here. What is it you have to be careful of in number 4? Read it over and answer. Number what? Inches to feet, or you could do either. I would do it. Why am I thinking I want to do feet to inches? Because you get, all right, so 2.5 inches, right? Convert that to feet. Isn't going to be kind of awkward to work with, right? You could do it, but I don't know. 6.5 dozen of the others, they say, right? But yeah, check your units, right? Because inches, right? Oh, 27 feet, right? And they want the answer in cubic inches. Okay? So this, let's take this 27 feet. What is that in inches? Say it again. 324 inches, okay? And now you can do stuff with it, okay? Of course, you're also going to need, you got a half cylinder on top, you're also going to need a radius, aren't you? What's that radius? 1.25. It's hard to squeeze in there, right? But you got it. Now you can just go to town and add a couple things together. Should be. Is that right? Oh, yeah, it is. Okay. What's the height of the rectangular prism, guys? Hmm? That 2.5 is the height of both of them together. 1.2. Isn't it? It has to be 1.25. So if that is 1.25 right there, right? The other radius, it's 2.5 minus 1.25. The other 1.25. What do we got? Should have gotten 1807.7, right? So right here, I mean, like, once you get to this point here, like you've written about, at this point, like if they want it, just, you know, putting pi in the calculator, after you write this out, you can just put that whole thing right in your calculator if you want. And that's enough work for me, right? As long as I see you knew how to do that, I'm assuming you can push buttons on your calculator, okay? It's going to be 1807, and it's cubic inches. What is your question, Guy?
So when you did the volume of the rectangular prism,
Mm-hmm.
why is it 2.5 plus 1.25? I thought it would be
Times. That's the base and height of it, right? Times its length, well, the height of the prism.
Oh, I added the whole height instead of just.
Yeah, that 2.5 is the includes the half cylinder, and 1.25 of that is the half cylinder, right? Okay. Yeah, so that's an easy one to. There's so many numbers in there you got to work with. It's an easy one to lose track of what you're dealing with. All right, number 5. So think about this one. Make a nice sketch of it. Okay. Do you have issue there, Olivia? No. Good. Okay. Let's go to number 5. Read it over. Check your units, right? What's the catch with this one? Somebody? That's the sketch. It's a catch. What's the trick?
You have to subtract a half a foot from the height.
Yeah, they're only filling it to within a half a foot from the top, right? So how tall is the basin? 3 feet. How far is the water going up? So how high is the water? So the water 6 inches high?
Oh, it's half a foot from the top.
From the top, yeah, right? You're not gonna fill anything right here. Everybody have a swimming pool? You don't fill it right to the top of the brim, sometimes accidentally, maybe, or if it rains a lot, but that really doesn't work out well. So, you know, really about half. So this is 2.5, isn't it? Right? Now you need is the radius. What's the radius? 4.125. Everybody agree with that? 4.125, because it's half of 8 1/4, right? We can just, you know, we can put it in a calculator, so we can go ahead and use the decimals in there. And now it's just a matter of plug and chug, right? Everything you need. Plug and chug. Huh? Yeah, and we got 134. What's a long way? You found the volume of the half a foot? And subtracted it from the volume. Okay. Well, it's a matter of where you do subtraction, right? That's valid, but yeah, it's a long way, which you correctly recognized, right? But in this case, we can do our subtracting right here, right? So volume equals pi times 4.125 squared times our height of 2.5, which gives us 134 cubic feet. Okay? We all happy with that one? So the only thing you got to read it carefully, okay? there's more than one of the agreements questions I see where they do sort of like within half or the top or something like that. Okay? All right, let's move on to number 6. The number 6, I'm going to show you a way to work out like your units properly using unit converter. I think I mentioned it yesterday. Right? When I was a kid, they called it unit conversion. I think they call it unit analysis now. But apparently some smarter people come along and give it a different name. Like junior high is now called middle school because we're better than people back then. You know why?
Because they're, I don't know, they're just not interested. They do the function class and I don't anybody.
Well, they should rename high school too, because look at you people. Yeah. Okay. Anyway, let's read that over. And I'm going to show you a little trick. Not area, we should find the what? The volume, right, of the barrel of fuel oil. We'll need a radius, won't we? What will be the radius of it? What'll be the radius? So that's pretty simple. 9 equals pi r squared times its height, right? 33.5. So what's the volume of that thing? You go out like 4 decimals.
I got 13,086.9.
You got it right. 13,319. What? Not comma again. Point. I got 8620. No.
I didn't round it.
Yeah, I didn't get 8620. I
You
got 5988.
I just didn't round it.
Well, you got it round properly.
Because when I grabbed
I mean, it's kind of simple, right? So it's a good one to kind of get a feel for this unit. This is where I'm going to show you the unit. So now we got to convert from, what is this, cubic inches? So I want to make sure I put that in there, right? Cubic inches to gallons. Okay. Yeah, we'll get that in a minute, right? No, it's set to the nearest what? 10, right? Every year. So, you might be thinking, okay, oh man, do I multiply by 231 or do I divide by 231, right? Does any of you take like a half a second pause and try to figure that out? Or do you all know it right away? Okay. When they get a little more complex, you might go, oh, gee, I don't know which one to do, right? So, let's set it up this way. I want to convert these cubic inches into what? Gallons. So I need to set something up so that the cubic inches cancel, the units cancel, right? So the ratio they gave us is 231 cubic inches, right, in A for 1 gallon, right? Could I also write that ratio the other way? Or I could write it as what? 1 gallon to what? 231 cubic inches, right? So I'm going to take this cubic inches and multiply it by one of these two ratios. And I want what to cancel? The cubic inches. So which one of these is going to make that cancel? Because it's in the bottom, right? Does that make sense? Right? So that really tells me to divide. So what I do is I do 13,319.8620 cubic inches. I keep my units in here, multiplied by this ratio, 1 gallon over 231 inches cubed. Now, these are top and bottom, so they cancel, right? The inches cubed goes away. What unit is left? Gallons. And so now I know that in my calculator, the bottom of a fraction always means to do what? Divide. See, so it means like if you wonder, do I multiply or divide, right? This is like happens automatically. So I just take that number in my calculator, divide it by that one. Everybody trying to get the unit conversion thing now?
Also, isn't it common sense for that?
It is, and this is a simple, right? This is a simple example. Yeah, I mean, you probably looked at it and say, yeah, okay, I gotta divide that. But a lot of times, like, sometimes they're gonna give you problems where, you gotta convert, like, feet per minute to kilometers per day, and you'll have to go through, like, multiplying by 3 or 4 or 5 different ratios, and then figure out multiply or divide by each one of the, right? What's that? Yeah, let's quit. And this one's a little meatier. 57.7 and gallons are what's left. Okay. All right. So, yeah, common sense there, right? You probably figured out. But now the next one, okay. I want to use this technique to get the units that they want. So let's read over the next one. So this will be the last one we do, and we'll take a break. Okay. So read that one over. We've got 2 people with pools, right? All right. We organize. We've got Teresa has a pool and Nancy has a pool, right? So I might start just right out of the gate here with the T pulling and do all of Teresa's stuff, right? And then get down below that and do all of Nancy's stuff and then answer the question. Okay? So what should we find out first about Teresa and her pool? The volume in what units? Cubic feet, right? So that's pretty, so she's got a rectangular prism type pool, right? So her volume, let's see, that's going to be 30 times 15 times 3.5, right? Yeah. Why is it 3.5? Why is it 3.5? Huh? Yeah, if you got to keep reading, right? Read everything. In other words, half a foot from the top. Okay? All right? Bet you somebody used 4 in there without reading the whole problem, didn't you? Yeah, I know. Okay. So it should be 30 times 15 times 3.5, which will give you 1, 5. You get 1575 cubic feet for that one, guys? Yeah? Okay, let's think about her rate now. Her rate up here. There's 2 ratios. What are the 2 ratios we can write for Teresa's situation? What over what? Come on.
3.95
$3.95 over 100 what?
gallons.
Put the gallons in there, right? The dollar is a unit, right? It's just there in the front. It just works the same. That just by convention it goes in the front. There's some country, I think, where they put it afterward, whatever their currency symbol is, or weird. Or what could we write it as? What's the other option for that ratio for Teresa? 100 and put the units in, right? Per what? $3.95, right? So what do we want to have cancel out in Teresa's situation? We want to have feet cancel out and then be left with what? Okay. Oh, by the way, we also have a ratio here that we need to use, don't we? What are the 2 ratios here?
1 cubic foot.
To 7.48 gallons or what? And so once you guys get to it, I won't require you to write out those 2 different ratios, right? I mean, it's just 2 options, right? I put them there so you can see them. But when you do it for real, I don't need you to write both of them out, okay? So we need to get from cubic feet ultimately to what? Nope. Money, cost, right? Like who paid more? So we need to get from cubic feet to dollars. So we're gonna have to do some canceling of units, aren't we, right? So let's start with Teresa's cubic feet. 1575 and put the units in there. Okay? So let's use this here to convert it to gallons. And then we'll do the cost. So what are we gonna multiply that by? We want the cubic feet on the bottom, right? Times 7.48 gallons per 1 cubic foot. Now, let's put the other ratio in there. I want to be left with dollars, so what's going to have to cancel now?
The gallons.
So what do I multiply by for this one? Well, I want gallons to cancel. Gallons is on top right now. Right. So I'm going to do $3.95 per 100 gallons. Okay, now just watch, right? So everything top and bottom will cancel. So they cancel, cubic feet, right? What else cancels? The gallons cancel. What's the only unit left?
Exactly.
Dollars. So I just take my calculator, I do multiply, and then what with the 100? Then divide. Just on the bottom. Okay, you get the idea? Does that make sense now, the unit analysis? It's unit conversion. Don't worry. So what's it cost her? And by the way, it's money.
$465.
So let me ask you guys a question. It's money, so do they have to tell you what they're out to?
Yeah. Well, no, it's 3.
It's always 2 decimals, right? What is it?
465.35.
Okay, you mean $465.35?
Yeah.
Okay. I like how you guys say that. What did you get?
I got 62.
Did you do 1,575 times 7.48 times 3.95 divided by 100?
I divided it, but I didn't do the times type off.
Yeah, well, okay, there you go. You got that. I just put a box around so I can find it. Now do Nancy. Got it? It'll work the same way, except now we got a different volume. She has a differently shaped pool, right? And she has like a different water usage situation, cost structure, okay? So she's got the circular pool, right? So Nancy's volume going to be pi, the radius is 12, right? And still 3.5 feet, right? So that gives us 1583. Well, no, just 1583 cubic feet. So now we got to go to her. You didn't by any chance use Teresa's cost structure for Nancy, did you?
No, I got 1583, but then I divided
Okay,
it by
well-
6,000.
let's use our unit conversion.
No.
Let's use the unit conversion method. So she has a rate of $200 per 6,000 gallons, and we're still using this, okay? So let's convert her cubic feet to gallons first. Okay, so 1583 cubic feet multiplied by what?
7.48 over 1.
Gallons per 1 cubic foot, right? And now let's put her cost ratio in there. What over what for her cost?
$200 over
Dollars on top, gallons on the bottom, right? $200 per, is it 6,000? And look at cubic feet cancel, gallons cancel, dollars are left, multiply, divide. Try it now. Did you get it? Did you get 134.79? Huh?
I didn't have one at 394.
Wait, let me. Wait. Maybe I copied it. Let me double check.
394.
So I copied something wrong. So it's $394.69. Now we have to answer the question, don't we? What was the actual question?
Who pays more?
Yes, who paid more?
There,
Right, so if you don't do, like, if you do all this work and don't write the following. Teresa paid more. You will lose many, many points.
Teresa.
Teresa.
Yes, it's pronounced Teresa. Okay?
But did you spell